Okay. Today, we're going to do some linear functions today. We're going to graph, we're going to do some piecewise, we're going to do some other stuff. It's pretty straightforward, but we have new types of problems I want to cover today, not just, where I give you, your formula and you have to go graph it, but actually give you some different information. We have to go to the other forms. And the idea today is I want to go through those other forms and kind of talk about, what standard form is, general form, the special cases today, kind of get through that stuff. We'll see kind of where we end up. My goal today at some point is to finish those last two graphs. We should have two graphs left that are free on there, and I want to try to get to those two today with some of these other forms. So that's kind of what I want to do. Make sure you have your notes out. I'm going to put a graph up here on the board here in a second, and we'll get started. There it is. Perfect. Okay. Now yesterday we did point slope form. That was the go-to form. Now that was this one. This is point slope form. What do you remember? What was the purpose of this form, point slope form? Like, what do we use it for?
Find a formula.
Find a formula when we're given what?
Data.
Data. Okay, that was a big thing, right? You're given information, you're given a graph, you're given some form of data, maybe it's coordinates, and you need to immediately go into a formula. This is the go-to. That is your point slope form. That's the top one. Okay, the second form that we did yesterday, and we ended the day yesterday with this one, was slope intercept. That was the one that I think we did 3 of those right at the end of class. Why do we have that form? What's the purpose of having the slope intercept? The second.
Find this. I don't know. The slope.
No. Well, we know slope if we had it, but what can we do with that? What's the easiest thing we can go towards?
Graphing points.
Yeah, graphing it. You can go to points, you can go to, if you had slope, you had a point, you can immediately graph that thing. So you're given a formula and you need to go look at a picture of it, visual representation of it. So the different types of relation, right? Those are the two go-to. Like those are like the ones I use more than any of the others. There is a purpose to the other ones, which we'll see today, but those are my go-to. Okay. Is there any questions with the setup on those, like what the parts are? Like a slope, or what a y-intercept is, or just what one of the coordinates is? The coordinates are? You have to subtract them. Okay. Now, let's get to the other forms today. I want to go to those other forms, talk about how to graph them, how to go to other parts of it, and then we can get to these other cases. Okay. All right, let's go to standard form first today, because I want to start there and kind of work my way to the end. That way you have all the different forms. So let's start with standard form. Okay, on standard form, the basic principle of it is if you're given standard form, it's because you have a formula. And what you want to do is you want to solve for missing terms. So what I mean by that is like the whole purpose of this is it's used for systems. That's like the big purpose of it. Back at the start, it's used for systems of equations. That you're given like 2 equations, 2 formulas, and you can actually solve for the other one because this form looks like this. It's ax plus by equals c, where a, b, and c are just our whole numbers or integers. So a, b, and c belong to the whole numbers, or I don't know why they always use a weird double line w, or they belong to the integers. Or they can be positive, negative, whole numbers, that type of thing. Some books say that you can't have like a as a negative number. It really doesn't matter. I just don't want it ever as a decimal or a fraction. They have to be kind of nice numbers. Again, what this stands for, this is the belong to symbol, is like an E with a little line It's like a C with a line in the middle of it. And then Z stands for the integers, and then whole numbers are a big W. That's the college term for like the symbol form. But they can be any type of numbers. The X and Y are variables, obviously. But if you're given one of these forms, let's say that I was given, my numbers are 3x plus 2y equals 4. Let's say that that's my problem. And I want to go to like graph it. This is not the go-to version for graphing. Like, I would not want this form if I had to go graph that. So what I would probably do is try to rearrange it to one of these other forms. Like, go to the one form that you can graph immediately. Like, I want to go to slope-intercept form. So, slope-intercept forms, you got to know like the forms off the top of your head. You got to kind of know what the formula looks like. Slope-intercept form, you got to get the y by itself. So in this one, I would have to subtract the 3x over, right? I'd want to do that first, like this. And then divide by 2. That way it looks like the traditional form where you use the same. So divide both sides by 2. Oop, got an X. Okay. Now I can go graph that. Because now you know your starting point if you have slope-intercept form, because I can just rearrange that thing. That I'm going to start at this y-intercept. So I'm going to start at 2. So that's 2 here, positive 2. And then my slope is to drop 3, run 2. So because this is slope, which is rise over run. And it doesn't matter where the negative sign goes. I typically put the negative sign on the top because I want to go either up or down, but I always go to the right. So drop 3, run 2, drop 3, run 2, drop 3, run 2, that type of thing, and there's your line. Okay, questions with what standard form is. Now, again, what I talked about earlier was that you're given a story problem, right? You're given something a formula where you're trying to solve for missing terms. One of the things that you did like in geometry days or maybe even algebra 2, you come up with like a story problem, you can immediately go to a formula. Like, for instance, maybe you're in a shop and you're going to buy 3 items of this particular price. You're going to buy 2 items of this other price, and you're going to spend a total of $4. Okay, so the X and Y represent prices, and the 4 represents a total price, so $4. So maybe they're cheap items. Maybe they're just a few pennies or quarters, whatever it is. But you're buying 3 of the first item, 2 of the second item, and you're spending a total of $4. You could have a story problem there, and then maybe you had somebody else that went and bought the same items. You can now compare them and solve it as a system. We're not doing systems, by the way, but that would be a purpose of why we'd have that form. Okay, questions on what standard form is and the purpose of it. We will see systems, I think it's one of the middle chapters that we do. We go into, the next couple chapters we'll go into graphing quadratics and polynomials, and we'll go into the hyperbolas and parabolas. Then we go into the trig functions in like January. And then right after trig functions, we go into vectors, which is something you probably do in physics and chemistry, or probably physics more or less. But then we go into systems at that point. So we'll review systems, but we do it for like 3-dimensional objects. So free space. But that's where you'll probably see them again, the standard form. Because usually I try to avoid that form. I usually like the other forms. Those are my go-tos. Okay, questions, concerns about the first one? Perfect. Let's go to the second type. I guess fourth type, technically, but second type today is general form.
Did you want us to graph that on the board?
No. We'll get to the graphs later. I'll have you draw a couple later. Okay, general form. This form is really good if you have a formula. So you have the formula again, and what you need to find is, x-intercepts. Or instead of calling them x-intercepts, sometimes they call them the zeros. Zeros of a function. It's where you're crossing the x-axis. It's really good for factoring, basically. That's kind of the go-to version. In fact, we've actually done that. You just didn't realize that you've already started this concept. Is that when you're graphing functions like what we're going to get in this next chapter, when we do like quadratics and polynomials, and we eventually do hyperbolas and parabolas and stuff. General form is where you want to get everything to one side of the equation. So you've done this probably a lot in Algebra 2, but this is what the form technically looks like. And I know it's going to look very kind of similar to what we did earlier. I'm going to make it a different letter than what the book says. This is the form. That's the equation form for general. It has a 0 on the right or left side, just there's a 0 there, and everything else is on the other side. But the book has the letter C right here. I'm avoiding that because it looks like standard form. Standard form, if you're bringing that C across, it'd be negative, so this is a different number. So I just put D instead. But it's just one step difference from general. So I could make this function into general form by just moving the 4 over. So 3x plus 2y minus 4 equals 0. Now I'm in general form. Again, why we'd actually choose to do that is if you're given a quadratic, like a really big problem where there's a bunch of x's, you can eventually factor things apart, and you want to take that equation and get the 0 on one side, so you can figure out what would make all those x's zeros. That type of thing. Now, on a 2-variable problem, I probably wouldn't do that, but if it was a single variable, I could. So, but this is like the form that we're going to use later. So you're going to see that in chapter 2, chapter 3, like I'm going to say put it in general form, so get everything over to one side with 0 on the other side, that type of thing. Questions on what general form is? In fact, you've been doing it since Algebra 2 days. They just probably never told you that it was called general form. When you had problems like this, maybe you had these problems, I have no idea. Maybe you had problems like that, I don't know. And you had to like bring things over and factor and figure out what solves that problem for x, bless you. You'd have to move everything to the one side. X squared plus 4x plus 3 equals 0. And then you can factor this thing apart. I don't know how many people actually had to do that back in Algebra 2. I did it a lot when I was in school. That was just something that we did quite a bit. It was just solving rational expressions and normal polynomial expressions. Okay, questions on what general form is used for? Okay, we're not going to see that one a lot yet, like the purpose of it, but I want you to know it at least. All right, let's do the special cases, and this is where we're going to actually graph. One of our graphs out of the 4 that we have is going to be a special case one. So we're going to do these here in a minute. So kind of get that graph ready to go. I'll tell you which one I want you to graph here. All right. The special cases are when you have a horizontal line and a vertical line. So, for instance, so special cases. And I'm going to try to explain the special cases in kind of my own terms and how I would use it. So the first one, let's talk about a horizontal line. Okay, horizontal line. Horizontal is like flat against it, it's like the x-axis basically, but how you'd actually look at it, what the formula looks like, is it looks like this. Y equals a number. Whatever number you have. Positive, negative, it could be decimal, it could be a fraction. That's the formula for horizontal line. It is basically in slope-intercept form. You just don't know it. It's just y equals a number. How I think of this, and this is my own way of doing this problem, is that when it's only one variable, like y, this is the only axis that you actually intercept. This is the only axis that is intercepted. So crossed. That's how I think of it. And then this is the number that is actually the point of intersection. That's just how I think of this problem. Because some people, like, they try to memorize certain things about it. It's just, if they tell you y, I'm hitting the y-axis. If they told you 2 letters, like x and y, you're hitting both. Like in that problem over there, did you see that it actually hit both the x and y-axis? Because there was 2 variables. It had x and a y. Well, when they only have one, it's only hitting one axis, like actually passing through it. So like for instance, maybe this is y equals 4. I'm only hitting 4 on the y-axis. So it's like this. So I'm hitting 4, and it's just passing through it. And notice I'm not going to ever tilt towards the x-axis. That's the concept of a horizontal line. That's just my way of thinking of it, so you don't really have to think too hard. You're only hitting the y-axis at that specific number. Make sense? Now, I always get that question, well, Ward, what if it's y equals 0? It's always a question I get, because I try to explain it this way all the time. What if it's 0? You'd be on the x-axis, right? Because you're hitting y right here, and you're going like this. Did I ever leave the x-axis?
No.
No, so I'm not intercepting it. I'm actually just lying on it. It's not intercepting. Intercepting means to cross through it. I'm just lying on top of it. I'm actually collinear or coinciding right on top of it. That isn't passing through it, it's on it. So there's a difference. The only axis I actually intercepted was the y-axis, where you passed it, you went through it. So there's a clear difference there. Okay, do we understand what a horizontal line is? Okay, second one is a vertical line. Vertical line, obviously you probably already tell, it's x equals a number. Because you're only hitting the x-axis, and you're only going to be intercepting at that one location. Stop the camera here. Okay, so let's say it was x equals, let's say 8. X equals 8. Well, I'm only hitting the x-axis right at 8, so I find 8 on the x-axis, it's over here, and then I'm going to draw a line that's going up and down on it. It's not going to hit the y-axis, it's not tilted, because it doesn't have 2 letters. Equations that have 2 letters have to hit both axes. That's something that, I don't know, I figured out a long time ago, but the reason why I always thought about it is because in college, when you graph 3-dimensional lines that go x, y, and a z axis, where you're going like in 3 space at a weird tilt and at a certain angle, if it doesn't have 3 letters in it, you're not hitting all 3 axes. You're only hitting 2 of them. And it always surprises me when you try to explain it that way, like this concept, to a math professor in college. Like, they don't even think of it that way. Like, there's only two letters, you're only hitting 2 axes, so it's like flat, it's 2-dimensional. And then you start to see the wheels turn their head like, yeah, that makes sense. So, all right, questions on the two types of special cases? Okay, we're gonna graph these in my next one, because does everyone have their graph paper ready? Does anyone need that graph paper? Everyone's got one? Okay, so on your graph paper, we're gonna do a piecewise function one more time, and we're gonna do it with some special cases in one of my other ones. So here we go. So my function g of x, we'll call it that. So we should be on the 3rd graph now. Curly brace, and we're gonna do a couple different ones. So we're gonna say x is equal to 4. X equal to 4 for any x that is less than or equal to -5. All right, let's go y equals 4, sorry. Y equals 4. Sorry. Y equals 4. For any x that is greater than -5. Now, your book will write it like this, by the way. They won't actually put a y out front of it. Because the reason why they're not going to put a y is that this represents y. So, this is just the name of the function. So, if you ever see this in your book, this whole reason I put this there, they just see a 4. It's hitting the y-axis at 4. It means this. Y equals 4. Keep that in mind. Okay. Let's do another one. Let's go with 3x plus 1 for any x that is greater than 2. And yeah, let's just do a 2-part piecewise function. So I want to do a special case here. That way you can throw it in there, you can see how to work it. Okay, so this only has 2 parts to it, so it's a 2-part piecewise function. On the top one, on the first problem, what's the first number I'm supposed to plug in on that top equation if there was variables there? On the top one, what number should I actually plug in if there's variables? What is it? -5. You're supposed to plug that in. The problem is, I don't have a variable. You still have to start at -5 on the x-axis. So here's -5, 1, 2, 3, 4, 5. There's -5, and the answer at -5 will just be 4. And I can fill that dot in. The reason I can fill it in, it has a little bar underneath, so I can include it. That's the first number. Even though I couldn't plug the -5 in, because there's no variable to plug the -5 in, the answer was going to be 4 no matter what. It was a constant number. The answer is always 4. Now, the next part, because that was the first dot, I always use this number no matter what it is. Even if I can include it or not, I always start with that number. What's a number that's clearly less than or equal to -5? No, -6. -6, and that answer would be 4 again. And then the next one would be 4, and they'd all be 4. So this is what it's going to look like going this way. And I can draw an arrow because I'm going all the numbers less than -5. And all the answers would be 4 going to the left. Yeah, common misconception. Numbers less than -5 have to be -6, -7, -8, because you're drawing a number going to the left. All right, the next one. Now we're drawing a linear equation. This one, they're both linear, but this one is going to tilt now. And we're going to start with what number first?
2.
2. It will be an open circle there. The reason why you have an open circle, they don't have the little bar underneath it, so you're supposed to not include 2. You're supposed to be just greater than 2, like 2.1 for 2.2. You can use decimals. But we're going to start with 2, and we'll just put an open circle there. Plugging in 2 here, so if I plug in a 2, this is what I'm actually doing here. So whatever this answer is, it's 6 plus 1. When I plug in a 2, that answer is the coordinate that I'm drawing. So I'm drawing 2, 7. So 2 over, 7 up, 1, 2, 3, 4, 5, 6, 7, and there has to be an open circle there. Make sure it's open, don't close it, because I can't include it. All right, and then now I have to pick numbers that are greater than 2, so the next number I'll pick is probably 3. So that's 9 plus 1, and this turns out to be, if I plug in a 3, it turns out to be a 10. So 3, 10, and that's a solid dot. So 3, 10. Now why it's a solid dot? Because you can use the numbers that are just greater than 2. So 3 works, 4 works, you can actually include those. And so now that I have my drawing, boom, there's my piecewise function. Okay, hopefully piecewise functions are not like overly difficult. I know a lot of you are kind of groaning and complaining yesterday. I don't know what happened to you in your mathematical past, but they're not that bad.
They seem that bad.
Okay, I think they're pretty straightforward. They're pretty easy. It's just you got to know how to start it. You got to know how to end it. I got to know if it's open circle or not. That's really all it is. Now, here's the weird part. In the homework eventually, not today, but in the homework probably tomorrow, you will have to graph something that's curved on a piecewise function. So you'll have to kind of see where this thing is going. So for instance, if I threw in an extra line in there, like where I said, in the middle here, I want to graph an x squared. That's not linear anymore, but you can still draw it. Because maybe I want to be from any number that is strictly less than or equal to 2, but greater than let's go -4. Now this problem is significantly harder than the last ones I've been doing, because this one requires multiple points of intersection to kind of see where it's going. I always do the first and last, and then I kind of figure out the middle ground, unless you knew the shortcuts for doing it. So this would be like the one that I would say like people would probably groan over, because you have to actually kind of plot, because it's not a line, so there's actually some curve going on there. It's a parabola, so it's just going to look like a U shape, but if you didn't know that, you'd actually have to plot a few points. So like the points I would do first is 2 and 4. So if I plug in -4, what's -4 squared? Positive 16, so it's way up here. So -4 is way up there at 16. And solid dot, open circle, sorry, open circle, way up there. And then I plug in a 2, and 2 squared is 4, so 2 over here is a 4, and that's a solid dot, because I can include that one. But something happened in the middle. Like if I plug in, let's say 0, 0 squared is 0, that's here. Well, I can already tell you, I already know what this thing's doing, but if you'd have to plot a few points and kind of see that it's doing something like that. It's a curve, it's a U shape. how I know that is that anytime your equations go from first degree to second degree or higher, now they're curves. Now they have some form of a curve to it, and you'll have to actually plot a few points. So if you had numbers like this, I would plot 0 for sure. That's easy. I'd plot like 1, -1, just to kind of see where it's going. All right, questions at all about if you had a third piece to it? Okay, the last problem of the day. This is my absolute last problem of the day. I want to see it. This should be your last one on your graph paper. Okay, your last one on your graph. This is the 4th graph, correct?
Yeah.
Okay, all right. So this one's going to be pretty straightforward, but here's what I want. This is the last one today. I want you, number 1, to graph this. I want you to graph that. Graph those 2 dots. Those are 2 dots that I want you to draw. Let's see if you understand what that tells you. So go draw that first. Seems weird. Put them on one graph together. Okay, once you have this drawn, I want you to compare it to your neighbors and see that you have the right dots in the right spots. There should be 2 dots. I want you to get familiar with this terminology. So, compare to your neighbor, are they in the right spots?
We don't have the same thing. Yeah. Little x-intercept. I thought the x-intercept was this special case vertical, because x equals a number.
Yeah. Alright, so,
Huh?
no vertical line. Just a dot.
No,
Just a
just
point.
dot.
Just a point. Okay. Alright. Does everyone have their coordinates that look like it? No. What I'd like you to do next, I think Ken's already did it, I want you to draw a line that connects both of those dots together. Draw a line that connects them. So we did 4, 5, and 2, 0, and it should look something like this. Try to do the best you can. What I'd like you to do now is come up with the equation for it. Yeah. So now you got to go backwards. So now that you have your information, you have your graph, you have this, I want your formula for it. I want it in point-slope form. I want the point-slope form equation for your line. That's going backwards than what we did yesterday. Yesterday we were doing a lot of graphing. I have to go backwards. Once you find it, I want you to put it above your graph. This is your last problem of the day. We will turn these in, so make sure your name's on it.
I don't know if I did this right, but it looks kind of right.
Alright. Once you have it, I'd like it turned in, please. I want to see what you guys came up with on your own without me telling you what the answer is. So, I'll take it as you guys are done and hold them up, we'll come around. Make sure your name's on it. tomorrow make sure you have your textbooks. Tomorrow we'll have actual homework tomorrow.
Because there's already a negative.
So we gotta do a bunch more examples.
Oh, but that's an X, yeah. Because they have 0, 2. I know, I'm just gonna hand it in. Where do you want to send it? I just put Eastern on there, but it's kind of obvious.
Yeah. I think you're fine. I don't think I'll confuse it with your brothers.
Probably not.
Covering it?
For some reason I crumpled up my small paper yesterday.
I wrote on this one, I don't know if I did it or.
Or, I don't know why.
Huh?
When in doubt, just hand it in. It's fine. I probably shouldn't do that,
Did you
but.
put your name on it?
Oh,
That's what I want. Like, what?
Because.
wrong.
So-
The only
Like, it's right here. Like,
0,
don't
see,
put your
0,
name there.
5. I did 0
No.
minus
I'm talking
5.
Negative 5.
And then I just counted the rise over run,
Yeah, so did I.
which was yes.
Negative.
And then it's the other two X's,
Okay.
which would be
Yep. Hey, if you're going for
minus
pre-S
negative
AT, I'll give you your homework right now.
6.
So,
Oh, you're so. I thought you were just supposed to.
raise your hand if you're going for PSATs. Okay, a lot of you. Okay, here you go. Page 175, numbers 46, 47, 54. And then page 188, numbers 14, 15, 22, 29, 30, 36, 38, 60, 64. 12 problems exactly, and I need to give you graph paper. So that's if you're gone tomorrow for sure.
Was it all in a graph?
It's all, they're all gonna be graphed, yes. So, there's 12 problems, they're gonna have you graph, the first ones are, the first 3 are, you guys. Okay, who else is gone tomorrow?
I might be, I don't know.
Are you done, Mom?
Yeah, me, Lord.
Any 2 are?
Okay, what I need help with is. Okay. Where does it plug it in?
You have your slope?
Yeah, I thought it was 6.
Okay, and then you have your coordinate behind?
Go for math.
So, are you doing Pointslope for me? So like, y minus y number, slope, x minus the x number, just use the coordinate, pick one of the 2 coordinates.
You'll see.
that I give
Because they
you.
could improve that.
And that's the number you plug in with that y minus number and x minus number.
I heard about that.
You can't mix 2 of them, I think you're mixing 2 of them.
I don't know if I'm going or not.
You don't know if you're gone? Who else?
I'm not.
Yeah.
I will be present. Oh.
Yeah, you didn't need
Can I
it.
just?
Keep it.
Okay.
Yeah.
You always
You'll
need
need it
nice
anyway.
graphic.
Okay. Alright, turn on the camera here, perfect.
My grade.
Oh my.